Hello everyone, and a very warm welcome to today's web seminar of the 5G-ACIA, the 5G Alliance for Connected Industries and Automation. My name is Andreas Müller. In my day job, I'm the head of communication and network technology in Bosch Corporate Research. But today I'm here in my capacity as general chair of the 5G-ACIA. And that's already the fourth web seminar of our current series. So we had previous events with presentations and also discussions on use cases and requirements, not public networks. And we also gave a general overview why 5G for the industrial IoT matters and where we currently are. And today I'm very happy that we have put together an exciting panel with experts from various fields, from the ICT industry and the OT industry, in order to discuss the topic a little bit in a more interactive fashion. And of course, we would like to keep this as interactive as possible. So that's why I already want to say that everybody's highly welcome to bring up any questions that you might have, any comments. So for that, please use the Q&A tool in WebEx that you hopefully can see in your window. So the theme of the panel is Industrial 5G Myths and Reality. Of course, there has been a lot of momentum around industrial 5G, so we have discussed this for a couple of years already. There are many activities ongoing in standardization, regulation, POCs. But the question is, what is now already reality? So how many factories are already running on 5G, or when will it be the case? And also, is this all this hype that we have currently, is this justified, or would it be a failure at the end, which I don't hope, of course, but that's exactly what we will discuss today and focus a little bit on. The good thing is that there are many of these web seminars these days. So personally, I joined, I don't know, many of them in recent weeks and months due to COVID-19, of course, attending some of them, but also actively being engaged in them. And there's a tendency to also have this more as a simu-live event. That means you record it and then you just stream the recording. And in the best case, you can enter some questions and they are answered just with text answers, basically. And here I have good news for you, because for us, that's really a live event. That means we are here as you hear us. Everybody, as you can see then from the video streams, is in most cases probably at home. And it's not just live, it's even better, it's in color. All right, so but let's just start. There's this one slide that I always present at the beginning of these web seminars, just to outline again why 5G actually matters for the industrial domain. So some of you may know this slide already, but usually we have new participants during every event, and that's why it's maybe a good basic introduction. So why is 5G important for the industrial domain, for manufacturing, Industry 4.0? 5G, of course, refers to the 5th generation of mobile networks. We had 4 previous generations, and the previous generations had in common that they were always focused on connecting mobile phones in one way or the other. The phones got better, we could do more things with the phones, access the internet and so on, but basically it was always about connecting phones and connecting people somehow. And with 5G, of course, it changes, because from the very beginning, 5G had a very strong focus on connecting all kinds of things in the Internet of Things. And this opens up many new applications in different verticals. Manufacturing, of course, that's why we are here today, but also in automotive, agriculture, healthcare, and so on. Now, at the same time, and this started independently of 5G, we have the developments towards Industry 4.0, the 4th industrial revolution. Also here, we had previous industrial revolutions, if you want. They have never been called like this before, but now since we introduced Industry 4.0, we also introduced the others here. Started with the introduction of mechanical machines really a long time ago. Then we had the electrification of industrial production, the introduction of the conveyor belts at the beginning of the 20th century. We had the digitalization, the automation, which started more or less in the 1970s. And now it's about Industry 4.0, and this is all about building cyber physical production systems. So bringing the IT world together with the OT world. So both developments towards 5G Industry 4.0 started independently of each other, but now it's basically natural to bring them together. So to bring 5G into the factory floor And if we do so, we can lift Industry 4.0 to the next level, and we can achieve unprecedented levels of flexibility, efficiency, productivity, and also ease of use, so to support the people working on site in an optimal manner. Now, the challenge is that the industrial domain is a very special domain. So mobile communications, of course, comes from consumer applications, connecting phones, but connecting a phone is very different from connecting a programmable logic controller, for example, in a factory. So in some of these challenges of the peculiarities of the industrial domain are depicted here. First of all, it's important to understand we are not talking about a single use case with a single set of requirements, but it's really about many different use cases with potentially very diverse and often also very demanding requirements. Can be cameras with high definition video streams, can be tiny sensors, but can also be closed-loop control applications with really tough requirements in terms of latency, reliability, and also real-time capability. Then we are typically talking about local deployments in a plant. So we do not necessarily need a nationwide coverage with a network, but we need local coverage with very high quality of service. The good thing is a plant is typically a rather controlled environment. That means you can have specific optimizations. And of course, the local nature is also a reason why these non-public networks, which we focused on during our last web seminar, play such an important role in manufacturing. So it's a controlled environment, but at the same time, it's also a very challenging propagation environment in many cases. So if you look at the picture here, which is taken has been taken in the plant, you see we have many obstacles. We have a lot of metal. We have potentially high interference, and these things really contribute to a very challenging propagation channel, very challenging propagation characteristics. And that's something we have to deal with, especially considering the very high reliability requirements that we often have. Then we are usually talking about brownfield installations. It doesn't happen too often that you build a new factory from scratch. So somehow we have to be able to bring in 5G into the existing factories, which are already up and running today. And that means we have to be able to interwork with what we have in use today. So we have to be able to seamlessly integrate 5G, for example, with industrial Ethernet solutions and other communication technologies that we have today. Safety and security are very crucial. I think that's pretty clear. Security because a lot of value is created in manufacturing. Production data is very sensitive, so you have to be able to really make this secure as possible. And safety because we have big machines and so on, and you have to make sure that nobody gets hurt and also that the equipment is not damaged. And the last thing I would like to highlight here is that there's simply an own language which has been developed over time in manufacturing. So people use certain terms. They are talking about things like cycle time, survival time, and so on. And of course, these terms have to be understood somehow by the telco industry, the ICT industry, in order to make sure that 5G at the end really fits to the needs of the industrial domain. And in order to address these challenges, this is exactly was part of the motivation why we established 5G-ACIA, the 5G Alliance for Connected Industries and Automation. We started in April 2018, so about 2.5 years ago. And 5G-ACIA is meant as a global forum for bringing all relevant stakeholders together in order to jointly shape and promote and drive industrial 5G. And all stakeholders, this primarily includes the OT industry, so the classical industrial players, machine builders, factory owners, industrial automation companies on the one hand, and the ICT industry with the infrastructure vendors, the chip manufacturers, and also the network operators, of course, on the other hand. So we are bringing all stakeholders together. We are discussing all topics that need to be discussed in order to ensure that this becomes a success at the end. And some examples are outlined here below. As I just said on the previous slide, it really starts with establishing a common language, which takes much more time than I would have expected at first. It's also making sure that the needs of the industrial domain are reflected in standardization and regulation, especially also in 3GPP, because the classical industrial players don't have a strong footprint in 3GPP, the telco players have. So we jointly discuss, for example, use cases, requirements, 5G-ACIA. It's very easy to become a part of the discussion, and then the inputs are brought to 3GPP via the established players which are active there anyway. So that means also small and medium-sized companies, for example, especially from the OT industry, can easily contribute that indirectly to this. It's also the other way around. So we jointly analyze how to optimally make use of 5G in the industrial domain. We identify relevant certification and testing needs, for instance. Of course, there are different requirements, starting with simple things like temperature ranges, but also safety-related aspects and so on. And for that, maybe we need special certification procedures. We try to develop a sustainable industrial 5G ecosystem. We just started a recent activity, or we will start an activity soon, focusing on profiling, generating device profiles, for instance, which is very important in order to grow this ecosystem. And of course, we also do a lot of promotional activities to inform everyone about the potential, the challenges of industrial 5G. And that's one of the reasons why we are having the panel discussion today. So here you can see the overview of the our current members. It's actually the status from the beginning of this month. So we just got 2 new members, which are not on the slide yet. But you can see that this is already a very good mixture between the OT industry and the ICT industry, and also from really different regions around the world, with members from Japan, Korea, Europe, of course, and also United States. So we're really covering all the regions. But everybody who's not part of 5G-ACIA yet, of course, is highly welcome to join us. So if you're interested to learn more about what this means and how you may get engaged, then just reach out to us, and we would be happy to provide you more information about this. So, and that's almost the last slide for the introduction. That's the structure of 5G-ACIA. We currently have 5 different working groups on the topics that you can see here. Then we have, these are typically virtual meetings. These already were virtual meetings before COVID-19, so this has not really changed. But then we have 4 to 5 plenary meetings per year, which used to be physical meetings. Now we have converted them, for the time being at least, into virtual meetings. So there we take decisions on starting, stopping work items, on approving content. We have an annual general assembly for major decisions on the way how we work together, or working procedures. We have the 5G-ACIA office, of course, which is supporting all the activities on a day-to-day basis. And then we have the 5G-ACIA board, which is the meta view and everything. And today, I'm very happy that all the panelists basically are also 5G-ACIA board members. That means it's also a great opportunity to get to know a little bit the people behind these blocks that you can see here, for example. Okay, so with this short introduction, it's now my pleasure to briefly introduce the different panelists. As already mentioned, all of them are also members of the 5G-ACIA board. I've put them here in alphabetic order. So I'll start with Christian Bauer. Christian works for TRUMPF Machine Tools. He's a lead developer for 5G and has over 10 years of experience in industrial data communication. And he's responsible for all 5G related topics within TRUMPF, and represents also TRUMPF in various relevant associations, organizations. He's the main delegate also in 5G-ACIA and also member of the board. So thanks a lot, Christian, for taking your time, and welcome to the panel today. So then we have Joseph Eichinger. Joseph has almost 30 years of experience, hard to believe, but obviously it's like that. In radio communication, he was working on different generations, 2G, 3G, 5G, and also Wi-Fi. He started with Siemens, then Nokia, and since 2013, he has been with Huawei in Munich. Since 2017, he has been the head of 5G Industrial Research and Innovation in the Munich R&D Center. First of all, he focused on 5G for automotive. Now he's primarily looking into a much more interesting topic, namely 5G for the industrial IoT. And he also has been the prime delegate for Huawei to 5G-ACIA since the beginning of 5G-ACIA in 2018, and is also a member of the board. So also thanks, Joseph, for taking your time and for being with us today. So then we have Riccardo Guerzoni. Riccardo is the manager for the core network group at docomo Eurolabs in Munich in Germany. He is responsible for the 5G core network standardization activities in 3GPP, with a special focus on 5G support for the industrial IoT and edge computing. And he also contributes to proof of concept activities on related to industrial use cases carried out by NTT Docomo in Japan. It's also a great pleasure to have you with us, Riccardo, and to bring in also the perspective a little bit of a mobile network operator like Entity Doc.
Hello, everyone.
Hello. So then we have Sylvia Lu. Sylvia Lu is with u-blox. She heads the technology strategy, standards, and industry alliances at u-blox. She's a multi-award-winning engineer with a decade of experience in the telco industry. Was also looking into 4 different generations, probably not from the very beginning, but at least during her career. She joined the 5G-ACIA board this year, and she's also at the same time the chairperson for our working group 4, the working group on liaisons and dissemination. So she's driving the collaboration basically with different external organizations, 5G-ACIA. And she also serves on various industry and national boards as a non-executive director. She provides industry-focused, independent advice to policy panels and the government on future plans for 5G developments. So also a pleasure to have you with us, Sylvia, and certainly good to hear then from your insights since you're engaged in very many activities. And then we have Andreas Pfaff. Andreas heads the factory automation European Development Center of Mitsubishi Electric. He started with Mitsubishi Electric in 2002, first of all staying for 2 years in Japan. And his long time experience with the Japanese culture and language, so even speaks Japanese. I cannot check myself, but whoever is fluent in Japanese maybe can give it a try. And supports his long time experience with the Japanese culture and language supports the daily bridging between Japan and Europe in terms of development and research of advanced technologies such as 5G, of course, always in the context of industrial automation. So thanks for being with us, Andreas, and also welcome to the panel.
Thank you very much. Hello to everyone.
And then last but not least, we have Benedikt Rauscher, who is with Pepperl Fuchs. Benedikt has more than 25 years of R&D experience in industrial automation and communication projects at Vision and now Pepperl Fuchs. Since 2015, he has been managing global IoT and Industry 4.0 projects at Pepperl Fuchs in Mannheim in Germany, and he also participates in several industry alliances and standardization organizations, such as 5G-ACIA, but also the Platform Industry 4.0 in Germany, for example. So also, Benedikt, a pleasure to have you with us. Welcome on board.
Thank you, Andreas. Hello to everybody.
All right, so yeah, really, I think an excellent panel. You can see we have a good mixture. We have a machine builder, a network infrastructure vendor, we have a network operator, a module vendor, and then 2 industrial automation companies, one more coming from the process industry, the other one from factory automation. So really a very good mixture. And now I just will disable my slide here, then you can always see the presenters or the speakers a bit better. I hope that makes it a bit more interesting. And we've prepared a couple of questions. I will bring up maybe the first question myself, but then really please feel free to put any questions that you may have into the Q&A window, and we will try to pick as many of them during the discussion. But maybe to start the discussion off, Christian, first question to you. So TRUMPF is a machine builder, so you are well known for laser cutting tools, so big machines that you put in a factory in car production, for example. So why is TRUMPF actually interested in industrial 5G?
Yeah, Andreas, thank you very much, and hello to everybody from my side. As a machine tool vendor, we provide our customers with machines for flexible sheet metal production. This implies that a huge range of different parts and products can be produced on that machines, and individualization of those products leads to a decreasing lot size, and the number of parts that are produced is decreasing. That comes with the increasing need of optimization of secondary processes, for example, billing, logistics, and so on. And for that, Industry 4.0 and in general, data communication and flexibility in general is essential. And so we see a huge potential in 5G as an enabler for smart manufacturing and for not only our machines, but also the services we provide for that machine. Thank you.
Okay, thank you very much. I think that fits to the first slide I ever shown, so that 5G supports the developments towards Industry 4.0, as you also said. So let's see maybe what Joseph has to add on that. Huawei, of course, is a major infrastructure vendor, so I don't have to ask you why Huawei is looking into 5G, but maybe the other way around. Why is Huawei so much interested in the industrial domain? Joseph.
Yes, that's very easy to understand, because since the beginning of 5G, maybe starting with the METIS project, the European project, Huawei was clearly pushing that 5G should not just connect smartphones, should connect everything. And everything means devices, but also devices in factories, in car domains, in e-health, and in all kind of business and domains. And we have also for sure identified factories as the most interesting, but also challenging and important domain for 5G, because I personally see the factories as the only ones that really needs all capabilities of 5G.
Okay, yeah, I think that's a very good point. So I mentioned also in my presentation that we have many different use cases with very diverse requirements. And basically, for those of you who know the famous triangle of illustrating a little bit the capabilities of 5G, as you just said, Joseph, of course, 5G can really use every spot on the triangle, basically, with 5G in the industrial domain with a corresponding use case. And as you said, I fully agree, it's certainly the most interesting and maybe even the most promising domain. So thanks for this introductory statement. Maybe just make the round here. So Riccardo, NTT Docomo is a major network operator in Japan, also highly innovative network operator. You're always looking at the newest developments, always have the ambition to be a front runner. So what is the interest of an operator like NTT Docomo in industrial 5G?
Yeah, let's say that Docomo has already a well-established presence in the business of enterprise services. And of course, industrial IoT can be an extension of this. We are aware that some specific knowledge and skills are required, because it goes not only in the area of 3GPP, but also beyond that. And so that's why it's important to be in 5G-ACIA to learn also from the OT side of the whole environment. And another thing is that obviously, as you said, NTT Docomo is a reference for the industrial market in Japan. And so the industrial ecosystem can be much more attracted by joining 5G-ACIA and being using the 3GPP 5G for if Docomo is paving the way for doing that.
Yeah, all right. Thank you very much. And I mean, I fully agree. So Japan, of course, we see that there are many activities ongoing, especially on industrial 5G, also non-public networks, which of course is also somehow supported by the regulatory developments. And maybe just for everyone in the audience, so we are actually planning to have a major meeting in Japan in March this year, which unfortunately could not take place due to COVID-19 at this point in time. The idea was to closely engage then also with even more companies from Japan and players there, but the plan is still to do that next year. So hopefully once we are back to more normal, so that we then can also be in Japan. And as Riccardo said, so there's many activities ongoing, and NTT Docomo is always certainly at the front line, I would say. Okay, so thanks for this initial comments from your side. So then when we switch to Sylvia, Sylvia, u-blox is a module vendor, of course. So you provide the modules that industrial automation companies and so on may integrate into their components to really offer devices. Also maybe for manufacturing in future. So what is your interest in the industrial 5G in general?
Thanks, Andreas, and apologize, my video is not working today. So as a module vendor, actually industrial is one of the three major sectors that u-blox serve. So obviously 5G established, and our focus also partially vertical industry is one of them. And we see increased demand from our customers when talking to them. You know, the automation, the manufacturers themselves, they're looking for devices, and then really be part of that, you know, ecosystem. Understand what is it actually, you know, distinguish from the reality to the hive. That's our role as well. Understand the exact requirements and what actually can be provided. standardized in 3GPP, and how we're going to provide the devices. So it's a integration activity. So we are also learning. So this is very interesting ongoing activity indeed.
Yeah, thanks a lot, Sylvia. And I mean, it's something that we heard now several times already. This learning, of course, everybody's learning because it's a completely new field. And that's, of course, why we also need this close collaboration, right? So everybody can bring in some views, and at the end of the day, we have to stick the different pieces together to make something meaningful out of that. So thank you very much. Then we maybe bring the same question, Andreas, to you. Mitsubishi, of course, is a big organization doing many different things. So why exactly also industrial 5G?
Yes, well, of course, we have a wide product portfolio, home appliances and so on, especially in the field of industrial automation. We have similar to TRUMPF, we have laser cutting machines, laser drilling machines, electrical discharge machines. But we also have a wide product portfolio of components which bring basically the life into the steel frame, so which make the steel frame to a real machine, starting from the PLC, from the HMI, the servos, the drives, inverters, and so on. And of course, it's interesting for us to see here where 5G is applicable in the components. And last but not least, we are the inventor and the strong promoter of our industrial automation network, the CC-Link network. And of course, wireless communication will penetrate the wired communication in the future. And especially here, we like to attend this, accompany this migration and build this migration.
Okay, yeah, great. Thanks a lot, Andreas. And last but not least, again, and we're going to always do it in the same order, so no worries. But Benedikt is still part of the panel, of course. Pepperl Fuchs is not maybe as big as Mitsubishi, but still the clear market leader in its segment, focusing more on process automation. And also here a question to you, Benedikt, why is Pepperl Fuchs interested in industrial 5G?
Yeah, Pepperl Fuchs invented the inductive proximity switch in the 1950s and is presented in 2019 its first completely autonomous sensor, so-called Wilson, which is working battery-driven and with a wireless data transmission. So as a manufacturer of industrial sensors and automation infrastructure components, we are always interested in communication technologies, wired and wireless. And especially with, we have some wireless hard components in our portfolio, and probably 5G could be an alternative or could become an alternative to, for example, wireless hard. So that's one of the reasons why we're interested in that.
Okay, yeah, thank you very much. Of course, wireless hard has been, maybe not everybody knows this from the ICT industry, it's an optimized solution basically, especially for industrial applications. But I think what you have in mind, what is always the case, of course, if there's then a more universal technology like 5G, of course, you can have more economies of scale and so on, and conversions of different technologies, which certainly is also a very important aspect of industrial 5G. So thanks everyone for this initial comments, initial statements, and just looking now at the questions that already come in. So thanks a lot. Already quite a number of questions. Maybe just pick the first one from the audience. So the question is a little bit, okay, we're talking about 5G in industry, but we have talking about this for 2 years or 2.5 years already. Many activities have been ongoing in standardization. But the question is really, when does it take off? So when does it start that factories deploy 5G networks and 5G use cases and so on for the real productive use? So and the question is even a bit more specific. So there are the different releases of 3GPP, of course. The latest one, which has been approved in June, is release 16, which includes many features that are relevant for the industrial domain, TSN support, ultra-reliable low-latency communication on public networks. But the question to the panelists is, do you see release 16 that this will basically give the trigger and is the start of 5G for the industrial domain, or do we have to wait until release 17 or maybe even a later point in time? So when do you think that it really takes off? we don't just see some pilots here and there, but more adoption on a wider scale. And maybe question is open to everybody, so whoever feels like having the right answer, just feel free to jump in.
Maybe I can start if nobody else is jumping in. For sure, Release 16 can be used for many applications already, and industrial communication is not just for very low latency and very extreme reliability stuff. It can also, we have many use cases, as you know from our white papers. That means Release 16 can be used for many applications already right now. But for sure, for the most demanding use cases, what we always discuss, motion control and this kind of things, we have to wait a bit for improvements coming with Release 17. Why is it not so much used at the moment? Maybe my personal feeling is OT guys and industrial company owners are a bit, let's say, concerned about this wireless technologies. And we have to convince all of the stakeholders that wireless could become a real beneficial technology for factories and for somehow mission critical applications in factories. This needs time.
But this convincement is not part of Release 16 or Release 17. It's not dependent on this. So it's already start now with Release 16. And for example, to come back to this wireless HART technology, that works with 2,400 baud. So I think 5G will be able to replace it even in Release 16.
Okay, so I think what I understand, and I would share this basically, so we have to distinguish between the features that are relevant, and of course, the longer we wait, the more supporting features will be there. But then it's really also establishing this trust, right? So knowing that you can really get ultra reliable low latency communication. It's not just a buzzword, and that needs to be tested in certainly in real world environments. I wonder if anybody else wants to comment, Sylvia?
Yeah, Sylvia.
There's two aspects to mention here. So first of all, obviously industrial IoT, there's different application categories. And if we look at the low end category, which is those, sensor connectivity to the sensors for industrial wireless sensor, for example, the current NR solution certainly that is mostly designed for broadband consumer sectors. So we're looking at a fit for purpose solution in Release 17. In fact, there's a new study ongoing, which is NR Lite, or they call it, reduced capability UE. So this is exactly designed for lower or mid-high IoT sensor type applications. But on the other hand, which I need to highlight here as well, that if we look at the narrowband IoT or CAT-M, those technologies, which actually is already part of Release 17, 13, 14, 15, and it's still continue evolving. It'll also be part. It was already part of 5G, improved by ITU. So, it's really looking at different application categories. If it's, low-tie IoT applications, we have the two already there. So narrowband IoT, CAT-M can do the job, and then NR in future Release 17 or even Release 18 can do the job as well. So, we don't have to wait. There are existing, 4G capability devices there, and some of the trials we're seeing and we participate are benefit from that.
Okay, thank you very much. Yeah, so it always depends, of course, also on the concrete use cases and requirements. So for some things, as you said, NB-IoT, CAT-M might be good enough already. I'm not sure, Riccardo, did you also want to add anything?
Yeah, I wanted just to add that actually the relation between the standard and the actual application in the field is something that is mutually dependent. So the standard is providing some initial kind of features like NPN or time-sensitive networking for supporting industrial applications. But the trials that are already starting in the field will provide feedbacks to the standard, and that's a continuous process that will be going on. So let's say that at the moment we are facing some initial trials with also docomo is participating in some of them with the major OT companies in Japan. And from that trials, we need to get feedbacks for the standard so that in release 18 and release 19, we can complete and do more to support the actual needs of the companies for the factory automation and process automation. So let's say the actual commercial deployment is something that at the moment we cannot really plan for sure in a time frame of 2-3 years. But let's say that that depends a lot on the actual contribution to the standard based on the knowledge that we acquire from performing trials with the OT companies. And that can speed up the actual commercial availability of the technology for the deployment in the factory.
Yeah, thank you very much. Very good comment. So it's certainly an evolution. It's a journey, starting with release 15, but then, of course, we learn, we bring in new features, new requests, new use cases, and then 5G will always become better and better and support maybe the industrial needs in a better way. So that's why I also think it's always important to understand 5G also as a platform. It's not something that you buy today and then it's forever like this, right? But it can then be upgraded. And with the virtualization that we have, it's more and more software. It's very easy then to upgrade it. So it can also then support future needs or maybe support current needs even better in future. So maybe we switch a little bit to the next question because time is really flying. It's always like this. It's such an interesting discussion. But one topic, of course, that cannot be missing in such a discussion is non-public networks. So we had a dedicated web seminar last time when colleague Atte Landsesami from Nokia gave an overview of non-public networks and the work we did in 5G-ACIA. And maybe to start a discussion here a bit is simply what role do non-public 5G networks play and which flavors will we see? And also related to that, will we use licensed spectrum for that? Is it also possible to use unlicensed spectrum? So how would you see that? Maybe Christian, it would be interesting to hear from you a bit what TRUMPF's view is on this.
Yeah, thank you. I was just having my mouse over the unmute button to jump in. I think it's manifold, this question. So it depends, of course, on the company size if a non-public network is the solution of choice. So, of course, with a non-public network, you have control. Here we come to the KPIs that are, or the things that are currently bringing some concerns from OT side as well. So who has control over the network, who is liable if something goes wrong and so on. So in Germany, we have, of course, the very good situation regarding that we have dedicated spectrum for OT companies, which, of course, is not applicable worldwide. But I think all different kind of flavors will occur depending on company size and needs. And one thing that is very new to and coming into OT domain with 5G is that the roles and stakeholders are growing. The number of stakeholders is growing. You do not have, even if you have a big company or huge premises, you do not have only your internal IT department that takes care of your fixed wire communication and Wi-Fi, for example. There will come vendors from ICT side. There will be MNOs that cooperate with you, provide you with spectrum and so on. So this number of participants is growing as well. And so with that, there's no clear answer to will it be non-public network on campus or not. It's more like depends on the situation, on your company, on the available spectrum and so on.
Yeah, thanks. I think also a very good remark. I think what the NPNs have started is just that we have more diversity, more options, right? Before there was only one option to use a cellular service. Now we have non-public networks in different flavors, as we have outlined through the last web seminar, and it's still developing the options that we have and so on. I'm just wondering, Christian, do you already know within TRUMPF, of course, you have your own production. Do you already know how you would like to use 5G? Will it be in non-public network? Would you like to rely on a public network, or is that still under consideration as well?
This is currently, of course, under consideration, depending on which facility we are talking about currently, of course. Since we have subsidiaries worldwide. That is, of course, a discussion where to place a non-public network, where a public network is sufficient, or even if 5G at all is necessary or Wi-Fi is a better solution, but that brings up a complete different topic. Another thing is, of course, the thing regarding available UEs, available modules, and so on. So currently there has not been made a final decision for all subsidiaries of TRUMPF, as you can imagine, if we have 77 subsidiaries worldwide. So depends on location as well.
Okay, thank you very much. So not sure if anybody wants to add something. Would be maybe interesting, Riccardo, to also hear your view a bit on NPNs. Of course, NTT Docomo is a public network operator.
Yes.
But you said already that you also have a strong enterprise business. So how do you see this development, and will there be also any offerings, maybe anything that you can share with us of NTT Docomo, maybe tailored solutions for NPNs?
Yeah, as you said, let's say the options that are given by the standard are a variety. So there are many cases of deployment of NPN that we can support. And so we go from the standalone NPN, where the whole non-public network is deployed in the factory, and there is everything, all equipments and radio access is in the factory. But there is also the possibility of having public network integrated NPN. So in that case, the NPN, so the non-public network, is actually part of a wider nationwide network, and this is realized as a slice of the network with the dedicated access. So Docomo is currently considering all these possibilities. So we don't exclude the standalone NPN, because Docomo could provide support for OT companies for deployment and design of the networks. But of course, the public network integrated NPN is also a very important topic that can be developed not only for industrial IoT, but also for enterprise services. So it's something that so the standard provides enablers that are going beyond specific scenarios or business scenarios. So all the enablers provided by the standard can be used in different environments.
Okay, thank you very much. So with that, maybe I'll just bring up another question from the audience. So Christian briefly mentioned already Wi-Fi 6. Of course, it's also a standard question. And maybe first of all, Joseph, the question to you. So Huawei, of course, is a strong player in the cellular business. Of course, we also have some activities in the Wi-Fi domain. So how would you see 5G versus Wi-Fi 6 in future Wi-Fi 7? So do we actually need 5G? Is Wi-Fi not good enough? Do you see that the technologies are competing or maybe even complementary in a factory?
Also, for sure, we are strong in mobile radios. It means we have a lot of interest in 5G and maybe beyond. But Huawei offers also products based on Wi-Fi 6 and so on, and quite good products. And actually, so I guess it's not, the point is not to say either or. The point is, for what do you need what? And if you have a certain situation, a factory, you have to think, maybe for this application, I have already a mature network management system. I want to reuse the Wi-Fi system as a management system of Wi-Fi, then go with Wi-Fi 6 for these applications. For some other applications, maybe Wi-Fi is not good enough. You know it already today. And then you should go with 5G. And everybody should really compare fair. Many people compare Wi-Fi from the radio point of view with 5G, but actually that's not the case. If you compare a professional Wi-Fi system with a 5G system, then you should also consider the network management functions and how to coordinate something. And in the 5G 3GPP definitions in the toolset, we offer a lot of management functions that make your life easier to control a big installation. With Wi-Fi, you are more or less alone, or you have to ask third parties to help you.
Yeah, thanks a lot. I mean, it's always good comment, right? We should not compare apples and pears. So it's always important to really look at the aspects that matter from the use case perspective. End to end is certainly one thing, and also then that we don't compare maybe average KPIs, but in the industrial domain is often about worst case KPIs. So what is the reliability that I still can get in the worst case? Because in the very worst case, if it's not behaving as expected, the communication infrastructure, then we cannot produce anything anymore. And that's, of course, something that should be avoided.
And actually, just to jump in, this control of resources, and resources means radio resources. This is a tricky part. And for this 3GPP, I spent a lot of effort to introduce a lot of functionalities to make this perfect, almost perfect. Perfect is nothing, but almost perfect. Yeah.
All right, thank you very much. So does anybody else wants to make a comment on that? Maybe Benedikt, same question to you. You also mentioned wireless HART already, which is used today, especially in the process industry. Wireless HART is based on 802.15.4, but would also be Wi-Fi 6 an alternative for you. So have you looked into that, or how would you see 5G versus Wi-Fi 6?
Yeah, as Joseph said, I think both could be an alternative, and for several use cases, Wi-Fi 6 would be an alternative, or 5G. I think another main advantage of 5G is that you can implement a seamless communication, a seamless connection. For example, if any UE is moving out of the factory, and first in the factory it was connected to the factory network, and now it moves out and is connected to the public 5G network, and communication is still remaining without the need to change the communication technology or the technology, the communication organization. I think that's a main advantage of 5G in this point.
Okay, great, thanks. So then maybe also to bring in another aspect again, many things are going already. 5G-ACIA, of course, is trying hard to make sure that industrial 5G becomes a success. But we are not there yet, as we have also seen or discussed before. And there's still some challenges to be overcome. So that's why I'm wondering if you could share a little bit your views on which challenges you still see that have to be overcome, apart from what has been said already, and maybe also non-technical challenges that may exist. Of course, we have to establish trust, as we have said earlier. We need these trials and so on. But is there anything else on top of that that still should be addressed, that still should be done in order to pave the way for industrial 5G?
Maybe I can start quickly. So the integration between industrial devices and user equipment, as it's called in 3GPP, is one of the main things that has to be resolved. So the availability of devices, industrial devices that actually are supporting the 5G access, and the features that are necessary, like time-sensitive networking or Ethernet type communication. So that is for me one thing that is not yet resolved, and it's necessary to address as soon as possible for progressing with the trials that we are doing.
And if I may jump in on this as a non-technical aspect, I think it's very important to point out for us as an OT company, and for many OT companies, 5G is not a business model right now, it's infrastructure topic. And keeping in mind that we have usually a brownfield situation with already established communication infrastructure, whether it be fixed wire or Wi-Fi, 5G has to earn trust and to show potential for future applications. For example, some killer applications, some benefits 5G brings with it that are not available with current technologies, as Benedikt mentioned, that you can have a on-premise communication seamless with an outdoor and landside communication, for example. And I think that's one of the key things that are necessary to make 5G a success, and where 5G-ACIA is hardly working on to show that potential of 5G.
If I might add, so from my point of view, also the trust in security in 5G is a point which has to establish in the automation, industrial automation industry, in the users. Then of course the confidence in the stability. So we all know mobile communication from our smart devices. Sometimes it's there, sometimes not. Also, same case of Wi-Fi. So if you look to the factories nowadays, basically wireless communication is there, but not that much. And I'm quite sure that a lot of machine builders will say, okay, you predict some high performance, high availability, but at first I want to see it probably from other applications, and then I will change, especially the industrial automation community, as Joseph already mentioned before, is somehow highly conservative with regards to changes in technology.
Yeah, thanks. So obviously, I mean, we heard this now several times, the trust is very important. And of course, trust is developed if you try things out, and it takes time, of course. Maybe thinking that one demo at a fair is not enough, right? You want to see it yourself. So obviously that's a key point, and also security, as you said, certainly is very key, of course, in manufacturing in general, but also then important to build up this trust. So there's one more comment from the audience that I want to bring up. So we had briefly the discussion between role of 5G and Wi-Fi 6. Maybe Sylvia, that's a good question for you to start with. Of course, there's something in between a little bit, if you want, which is 5G NRU. So there is starting with release 16. 5G NR, new radio can also be used in unlicensed spectrum, so in 6 gigahertz, for example, in future, which is currently made available or has been made available in the United States already. In Europe, it's still under discussion, and maybe other regions will follow. So what's your view on 5G NRU, and what role might it play in manufacturing? Do we actually need it, or is it more I either go for Wi-Fi 6 and then it's Wi-Fi, or for 5G in licensed spectrum? So it would be great to hear your view on that.
Thanks. Yeah, indeed, that's a very interesting question, because that's exactly debate, not just 5G versus Wi-Fi 6 or 6E, but it's rather NRU, unlicensed versus Wi-Fi 6 or 6E. So the new element that's been added recently was that standalone operation. So the cellular operation, cellular connectivity in unlicensed spectrum, that was not new. So previously we had LTE, LAA, license assisted, and that was defined in 3GPP, which rely on a primary licensed carrier. So you always need that assistant. But in the 5G, in particular the 16, now you can also do a standalone NRU. And that's when this interesting debate is starting, whether you are going to use Wi-Fi 6E or NRU. I don't know the answer. It really depends on the OTs, what their requirements are and what their infrastructure is set up. If it's a single network, if it's a cellular single network, there is potential feasibility here to operate, if there's a demand, in the air. But if there's existing Wi-Fi deployment in that factory, then why should you go with NRU instead of using the evolution of Wi-Fi? So I think it's really up to the OT really balance that initial investment and how they're going to sustain that investment, meanwhile be able to still provide a reliable service in the long run. But as a component vendor, certainly we're happy to explore that demand and see what's the best offer to suggest.
Thanks a lot, Sylvia. So indeed, maybe first of all, also here it's the same thing, right? You first of all, as an OT company, you have to understand which has maybe 5G NRU is better than Wi-Fi 6, or if it is better, and then also to establish trust. Yeah. And of course, my view is if you don't have the licensed spectrum, exclusive access to spectrum, of course, many of the use cases and requirements for which we particularly would need 5G do not really work that well anymore, right? This high reliability, high real-time capability, and so on. Of course, also depends on the access to the spectrum somehow. So does anybody else want to comment on this?
Yes, may I jump in? I think the non-public networks or the cellular, the campus network are 5G's most important feature. But in critical applications, it is absolutely necessary to own the spectrum to get that confidence to the network and to use it for especially those critical applications. So I think the isolated private networks are the only alternative, and that could not be NRU.
Okay, yeah, thanks. So I just see time is really flying. So I think we could continue a couple of hours like this. I think it's very interesting, but we are already approaching the scheduled end of the web seminar. So this maybe why I would like to bring up a final question to the panelists, and would be maybe good to have again the complete round, and maybe we could start this time or do it in the reverse order, starting with Benedikt. So it's very simple, and please reply shortly. So the question is simply, what is your personal view? So do you think that industrial 5G will become a success? And if yes, so when will it take off? So then we go back basically to one of the initial questions that we discussed as well. So, but if you would have to give a number, a year, so what would it be, if any?
A number of year is very, very difficult. So I would not give this, but I'm convinced that it's becoming a success, especially because of the non-public networks. And in Germany, we have already you can already buy these licenses, and that at a reasonable fair price. The price of the operators that are deploying the network, and you have to, as an OT, you have to use them. We have to discuss on this, but that's already going to be then, and that's the reason why I think that we will have private 5G networks in several years. I think 2 or 3 years that will be the case. Yeah.
Okay, yeah, but it's a good estimate, and not so far away then. So Andreas, would you share this view?
Yeah, so I would say it depends on the application. So if you look to supporting some technicians by AR or VR or whatever, or in brownfield condition monitoring and so on, so basically applications where the actual real-time control is not influenced, I think in such applications 5G will find its way very quickly, let's say 3 or 4 years. But I would say in the hard real-time communication inside of a factory, I would say, let's say 10 years.
Oh, so it's a bit longer to establish really sufficient trust.
Yeah, as I mentioned, the automation guys are somehow conservative now.
Right, yeah, I know what you're talking about.
Yeah.
So, Sylvia, how will you see that? Are you also, well, now we heard 2 or 3 years, we heard 10 years, so what's your point of view?
Well, if at the rule of thumb, for any specification in 3GPP, when it's got frozen, it takes 12 to 18 months for device to be available in market, right? So if we look at now, we are at release 17, so release 16 just finished, so we have some already features available for the industrial IoT. But OT, the industry adoption, that's very different to what consumer sector adoption rate are. So we normally hear about 10 years, 20 years, which is fine. But one important element to emphasize here is that actually private LTE network exists already, right? So there's some lesson we could learn from the past. How why do they choose that? How do they deploy that? And there's technology available in 4G as well, which we can already also start. So we don't have to, some applications, especially the low-cost IoT applications, we can already start with 4G. But for ultra-reliable latency applications, then we probably have to wait another 2 or 3 years, or maybe longer.
Okay, thanks, Sylvia. So then, Riccardo, and please try to keep it short since we are already running a bit late.
Yeah, substantially I agree. So for augmented reality and other applications that are using initial features of 5G, that will come soon, most probably in a few years. For most advanced applications that are mission critical, that requires to build trust, to evolve the standard, it will take much more, and I cannot predict, but Docomo is doing its best to make it possible as soon as possible.
We are sure about that. Thanks. Joseph, what is Huawei doing, and Huawei's, or your personal point of view?
So my personal point of view and Huawei's point of view is sometimes the same. I believe that 5G has a big advantage if you use it as an overlay network in brownfield application. You have already something running, you don't want to touch the essentials of your factory, then you can even use 5G as a kind of overlay network, maybe for video applications, for not so much critical applications, or even to extend the capacity of your network. This will go first. Then secondly, the dependency is always availability of terminals. And what Sylvia already mentioned is different classes of terminals. And this will come in the next years more and more. And then you have maybe low power devices with 5G, high power devices that can really be used in very small machines for your purposes. But this needs time. And I personally think that it will start for sure, and it will come to a kind of bigger business success in 3 years from now on.
Yeah. Okay, so 2 to 3 years, we heard it before already. And then last but not least, Christian, what is your view?
Yeah, I'm with my OT colleagues here, but I'm with Joseph as well. So I think, first of all, once UEs and modules are available for industrial use case, 5G has a huge potential in opening a second data communication channel without touching legacy installations and interfering with a smooth operating production side. I think that will be the first milestone. Once that's reached and trust is gained, it will go very fast. So I think with non-mission critical applications, it's about 2 to 3 years once modules are available, and as Andreas said, the hard real-time communication will take a little bit longer.
Okay, so it seems, at least on that topic, or that aspect, there's a similar view. So, yeah, I'm really afraid we are already at the end of the scheduled time. Really a pity somehow, because I think we could have continued the discussion for hours. And of course, we will do so, but in a different setting. So that's what we are doing every day in 5G-ACIA. So I really would like to thank all the panelists for sharing their views, their insights with us, for taking the time today. That's very much appreciated. Of course, I would also like to thank all the attendees, the participants, for tuning in. As mentioned before, slides and also a recorded version will be made available afterwards on our website, 5g-acia.org. And this is the last web seminar of the first series, but I also mentioned this already. We are working on a second series already, which we will then announce soon. And there are more exciting topics to be touched and to be presented. It's not fixed yet, but we have topics like security, industrial Ethernet integration, traffic modeling, and so on. So really all of these are relevant aspects that need to be considered, to be addressed when talking about industrial 5G. So just check our website regularly to not miss any of the future web seminars. Thanks again to everyone, to participants, the panelists, and also the 5G-ACIA office, of course, for making sure that everything runs smoothly. And I think and hope this was the case. Thank you very much. Have a good day, and hope to see you again soon. Goodbye.
Goodbye.
Bye-bye.
Take care.
Bye.